Good morning, Professor. This is our team presentation for Team 11 for you team assignment. The members of the team is myself, Hector Cachipeiro, Rashmika Rayan, Mucha Karika, sorry for the pronunciation, it's very difficult, Masaru Saito, Brandon Benita, and Arthur Banyan. Okay, first we have the stock data. Our client is Bridgewater portfolio, Bridgewater. From the portfolio, we only took 15 stocks of the 70 they have approximately. As you can see on the left part of the presentation, you have all the information for the sigma, tracking error, Sharpe ratio, and the location for each stock. And at the end, you have the sigma and the same information for the portfolio. Okay, as you can see on the right part, there's the optimized portfolio, where you can see the new sigma, tracking error, and Sharpe ratio, and the new allocation for only 7 stocks that we run on the optimized running code, and this was the result for the new portfolio. The details that we put on the allocation was maximum allocation of 20%. That's why we have 7 stock of 15. Okay, if you see the difference between the sigmas, you can see that the sigma is a slightly higher sigma on the optimized portfolio. It has a slightly lower Sharpe ratio, and it has a significant higher tracking error. This means that probably the newest stock that the portfolio has, it's as the tracking error is compared with the benchmark, we can say that these stocks aren't that similar to the benchmark. So probably in order to get a lower tracking error, we need to compare these stocks with a different benchmark.
We provided the correlation for each stocks, and as you can see, the left side, which is the 15 stock, the original portfolio, is you can see there are many the highest correlation pairs for the stocks. But we provided the other one, which is the optimized portfolio. Then the correlation is relatively decreased than the original one. And yeah, this is a chart for the comparing the benchmark and the original portfolio, and the other one is the optimized portfolio. So we provided 2 chart for the volatility of the comparing the portfolio and the benchmarks, and the left side is the original portfolio, and then right side is the optimized portfolio. But both of them are almost the same volatility and the returns. So it's not the change to be based on because of the changing the optimizing.
Now we have the efficient frontier for the optimized portfolio, and we chose the lowest Sharpe ratios in order to know which one we can substitute, because the code that we ran on R was based on maximizing the Sharpe ratio. So as you can see in here, with the highest returns and highest volatility, you can see that is the JD stock. But if we add an additional stock that is SBUX, it changes from 10% and around 1.75 expected return to 7.5% on volatility, and a little bit slow return that is around 1.3 something. But if we add another stock that's GNG, the volatility decrease from 7.5% to a little bit lower than 5%, but with a lot less a return. So we can say that, for example, between SBUX and GNG, we can actually take out GNG because we are earning almost 1% more with only 2.5% volatility. But as the objective of the portfolio is to minimize risk, adding GNG is a really good option. So in terms of risk, it's a good option. If we see the part on the expected return, it's not a good option. Okay, this was our presentation. I hope that you enjoy it. We will send you two codes, one based on 15 stocks and one based with 50 stocks, because we wanted to see the results and the difference between them to see how the optimization of the portfolio, it worked in different allocation and different type of stocks, and having that many more stocks, how it was the impact. So yeah, I hope you enjoy the presentation. I hope you enjoy reading our code. R.